Students, we know that the gravitational force is the attraction force between any two objects with non-zero mass separated by the distance. So, does the apple falls towards the earth or the earth moves towards the apple, or do both move towards each other? It's actually simple logic. This is the earth and this is the apple. Based on what we have learned about the gravitational force, both apply the equal force to attract each other towards itself. So, forces are equal. Which one will accelerate more? Based on the Newton's second law, we know that the force applied is the product of mass and acceleration. So, the acceleration will be equal to force over mass. Now, the acceleration is inversely proportional to the mass here. So, if the mass is more, the acceleration will be lesser. As the mass of the earth is much more than the mass of the apple, it is the apple which accelerates towards the earth and not the other way around. Hope that's make it clear. Now, the question arises, how do we quantify this force? To understand this, we need to understand the simple concept, and this concept is known as universal law of gravitation. So now here say there are two objects A and B separated by a distance d. The distance between centers is considered to be the distance between two objects and not this distance. Assume that mass of A is m1 and that of object B is m2. Here object A is bigger. Let's assume in that m1 is bigger than m2. The universal law of gravitation says that every object in the universe attract every other object with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let's repeat it. The force is directly proportional to the product of their masses and force is inversely proportional to the square of the distance between them. With this data, we can convert mathematically like this. So, if the masses of any of the object increases, gravitational force will increase. And more the distance between two objects, the lesser will be the gravitational force. Force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. This can be written as F is equal to G m1 into m2 divided by d square. G here is the universal gravitation constant. The equation can be modified and written as G is equal to F d square upon m1 into m2. The value of G is founded by Lord Henry Cavendish using a torsion balance. The universally accepted value of G is 6.673 into 10 to the power minus 11. What will be the unit of G? If force is Newton, as the distance is in meter, we have meter square, and as the masses are Measured in kilograms, we multiply kilograms raised to the power minus 2. This is the value of universal gravitation constant.